All right, here we are for Honors Physics Free Fall Questions and Problems. Take a look at problem number 1 from that problem set. So it says, if a car rolls gently, V naught equals 0, off a vertical cliff, how long does it take to reach 90 meters per second? So here's my cliff. Here we'll have some nice tufts of grass here at the top, and then right? Shoop, right? And, there's rocks and stuff to scree at the bottom of the hill, right? There we go. And there we go. Remains of previous cars that have gone off the edge. And so we're going to go ahead and just ever so gently, the car, gets to the edge and kind of, oh no, and just kind of goes over the edge. And so we're going to say that the initial velocity, we're going to say is 0 here. It just barely gets a little nudge and starts to fall. We know that as it falls, it's going to get faster and faster, right? And we want to know how far, faster, how far would it have, how much time, how long, we're going to assume that's time, I think is what they're looking for here, does it take to reach 90 meters per second? So if I think about this, again, when I do motion problems, I usually like to list out my motion variables. So I kind of see what I have to work with. A, V naught, V, delta xt. I get in the habit, I always jot them down that same order, same sequence. I kind of have that already set to go. At some point, it's going to reach some final speed here of 90 meters per second. Now, I'm going to go ahead and again, you can call, technically in a problem set, you can call whichever way you want to call positive, but it's really a good idea to indicate that on your diagram. I'm going to, for my own purposes, I'm going to try to stay consistent in these videos. I'm going to choose to always call up positive, okay? So this final velocity that I'm looking at here, I'm going to make this final velocity be a negative 90 meters per second because I want to go down. All right, I want to call down the negative direction. I'm choosing to call down negative. My acceleration due to gravity then is going to be, of course, a negative g, which we can label as negative 9.8 meters per second squared. Because the only force acting on this car as it's falling is the gravitational force. We are ignoring air resistance, which is what we will do typically in our calculations this year. Because if I add in air resistance, that force from the air resistance will be changing as it goes faster and faster, and it won't be a constant acceleration. It'll be more challenging. It's something we do next year in AP, though. So we'll say the acceleration is negative 9.8 meters per second squared. My initial velocity is 0. Final velocity negative 90. Like, oh my gosh, look, that's 1, 2, 3 variables. And we're trying to solve for how long it takes to get there. I'm pretty sure that they want us to find the time. You say, I would like to use a formula that doesn't have delta x. So the kinematics formula that doesn't have displacement is going to be this one. V is at plus v naught. Okay, so I'm going to go ahead and list out my equation. I'm trying to find the time. Now, some people are much more comfortable just putting the values in now, substituting all the numbers in and then rearranging. But for reasons that will become more obvious the further you go in the course, it's oftentimes going to be nicer to rearrange first with just the variables there and then plug the values in. So if I rearrange for t, I'll say that t is going to be equal to v minus v naught over a. Okay, do the algebra, that's what you get. And now I can substitute am I trying to find t? Yeah, how long it takes, yeah. And so I plug in my final velocity minus my initial velocity. And you notice that, final velocity minus my initial velocity, 90 minus 0, over my acceleration, negative 9.8, which is a negative 90. And so it's when you do it like this and you list out your formula and then you work vertically and then you put your values in like this, it's really easy to see, oh, V, that was negative 90. Initial velocity, oh, that was 0. The A, that was negative. You can see where all the things follow and it's easier to follow the work. Sorry, this is a little bit sloppier than I would like it to be. And so I can do this calculation in my calculator. Notice that that negative there and that negative there, they're going to cancel out. Which is helpful because, of course, we don't want our time to be a negative value. Our times should pretty much always be positive values, I would think, how much time elapses. So when I go ahead and I substitute that in the calculator, and I say I'm going to take 90 over 9.8. I get a value of 9.18 seconds. And that would be my answer. Now, if I was going to be super picky about like significant digits, I would say, hey, there were 2 sig figs here. That 90, is that just 1 sig fig? Should I be rounding this off to 9? Please don't sweat sig figs in this course. A few digits is usually all we need. Okay, don't sweat trying to be real precise about this. This isn't lab data. We can assume that this is infinite precision, and it's okay for now. So 9.18 seconds, and that would be it for that problem. But again, general procedure in solving all these problems, what I'd like to see in future work is I'd like to see a sketch. I'd like to see a list assigning values to variables. Always list a formula before you use it so we know where this calculation is coming from. It's usually going to be helpful to rearrange the variables before plugging the values in, show your values plugged in, and your answer. In other words, and this sequence kind of helps you logic through. Later on, it's really clear how you got to your answer when you're looking back at your work later. All right, that's it for problem 1.